Alright, so this is Module 2, Lesson 1. Okay, we're going to just have a little bit of some discussion talking about some things, and then we're going to go into doing some things. So as I talk about this, if you want to take notes, you're more than welcome to. But a lot of terminology will be introduced here, and this is where you're going to need some information. So we're going to start with these two segments right here. Okay, given two segments AB, segment AB, and segment CD, okay, which could be very far apart, how can we find out if they have the same length without measuring them individually? Do you think they have the same length? How would you check? So think about this. How would you check to see if these have the same length without measuring them? Okay, so if we're thinking about that, let's look at this quadrilateral down here, ABCD. Okay, all angles, angle A, angle B, angle C, and angle D, are right angles. Okay, the question is, are the opposite sides equal of length? Is side AD equal to side BC? Okay, later we're going to prove if they have the same length or not. Okay, and similarly, if we have angle AOA and angle A prime, O prime, B prime, okay, those little apostrophes are prime, can we tell if they have the same angle measure without actually having to measure each angle individually? And then lastly, here's a set of two parallel lines, line L and L prime, okay, cut by a transversal. This diagonal line is a transversal, and it forms angle A and angle B. Again, how can we tell if these two angles have the same angle measure when measured without actually having to measure them? So our goal through this module, through this lesson, is to figure out a way to do this without actually having to measure them. Okay, so when we have two geometric figures, two segments, two angles, two triangles, and so on, in different parts of a plane, okay, and a plane is just like a flat piece of paper or something, and we have to find out if they're in some sense the same. Okay, that's our goal. Okay. When we're looking at this, there are three standard moves we can use to move one figure on top of the other to see if they coincide or if they line up. So the key question is, how do we move things around in a plane, keeping in mind that lines are still lines after being moved, and the lengths of segments and degrees of measures and the degrees of the measures of angles remain unchanged in the process. So all that means is if we move a line, it's still a line. If we move a segment, it's still a segment. If we move an angle, it's still an angle. Okay, so we can move things around on a plane through the concept of transformation. And transformation is just the function that assists moving a thing. So we can denote this in a couple different ways. And when we talk about moving things, usually you're going to see me write it like the original line here is L, and the new line is L prime. Okay, so you'll see me say the original is, whoop, you can't see that, is L, and the new would be L prime. That little apostrophe just means prime, and it's the new one. You can also write this, you could write this in another way, where you can say the function of L and the function of L prime. It's the same thing, but I will mainly use this L prime. Okay. Okay, so what we're going to do is it's basically creating an image. So here's the first one. This is the original, and this becomes the image. So A, O, B prime gives us A prime, O prime, B prime. The prime just means that that's the new one or the image of the original. Okay. Now, as we're going to say map something to itself, we're going to map something. Think of this street map, okay? All we're going to do, a point on this street becomes a point on your paper. So when you're mapping each point to the street on your paper, so all you're doing is saying like, okay, here's a point, I'm mapping it. If I move it, I've mapped it to here. If I move it again, to here, to here, to here. All it means when we say mapping is that we're moving the point. Okay, transformations, like moving things, can be very complicated. But right now we're only going to be concentrating on the simplest transformations that preserve distance. Okay, a transformation preserves distance or is distance preserving if any two points P and Q Okay, so pretty much if we move a point or 2 points, they have to be the same distance as the original. Okay, so what that means, if I have a point P and a point Q, okay, as long as I move them the same amount in the same direction, it's distance preserving. So if I'm just going to go straight down, P prime, Q prime, in the same world that I actually move them exactly, they're the same distance apart here and the same distance apart here. That's all it means by that we preserve the distance. Okay, and when we preserve the distance between two things, okay, it's just called a rigid motion. So a rigid motion is distance preserving. Okay, and now we're actually going to move on to your lesson where we're doing this. So we're actually going to do this together. Okay. So here we go. Describe intuitively what kind of transformation is required to move the figure on the left to each of the figures 1 through 3 on the right. To help with this exercise, use the transparency to copy the figure on the left. So instead of using a transparency, you all should have a sheet protector, and it's going to work the same fashion. So what we're going to do is you're just going to trace this. Okay, and this is why we wanted fine tip, because you're going to trace these little bitty things. And I'm doing it on the inside so that the edges line up with the other ones. Okay, and all we're going to do is look to see how we get from this one to number 1, and this one to number 2, and this one to number 3. So if we were to move this, okay, it goes on the inside of that. That is probably what you guys would call a slide, but we're just going to call that the actual termination, or the terminology, not termination. Okay, so from the original to number 1, it is a translation, or what you guys would call a slide. Okay, and then go from the original to number 2. We'd have to do some sort of rotation. And then a reflection of some sort. So to get to number 2, okay, you could do like a translation. So they meet at a point right there, and then you could, well, actually, you could do this and reflect it. So you're going to have to do some sort of reflection to get it to there. And probably a translation of some sort, or a rotation. Okay, so when you do these, you can have several different options to move from one to the other. So the original to number 2. Okay, I'm going to say this is a slide and then a reflection. So a slide would be the translation. That's the terminology. And then a flip, a rotation, which is a flip. Okay, and then I'm going to go back to the original, and I'm going to just do a rotation or a turn to get to number 3. So for the original, to number 3, okay, we're just going to do a translation. We're going to have to slide it over. And then a not this. I totally did that wrong. Rotation, which is a turn. This one up here should have been a reflection. Okay, so I would take this for the original to number 3. I would slide it over and match that corner point, and then I would rotate it around. Okay, and in 8th grade in geometry, we're going to not use the word slide, flip, or turn. We're going to start working on moving towards translation, reflection, and rotation. Okay, so let's go ahead and flip the page. So kind of the same thing here. We have 2 segments. A, B, and CD, which we talked about at the very beginning. We looked at this picture earlier, okay? And now what we want to do is to determine their length without measuring them individually. Do they have the same length? How can we check that? Okay? In other words, why do you think we need to move things around on a plane? So in reality, the reason we move things around on a plane is to determine how to do if they have the same length or the same measure. Okay? You're going to take your transparency. Okay? We're going to trace one of the segments, and I'm just going to trace AB because it'll be easier for me to move it around. So I'm going to trace segment AB. Oh, make sure you get all the way to the ends. And then I'm just going to move it over and see if it is the same length. And indeed, segment AB is the same length as segment CD. So on here, what you would say is, okay, trace one segment and move it to the other segment to see if they coincide. Okay, and to answer why do you think we need to move things around on the plane, we move things on the plane to determine if they have the same measure. This allows us to know without measuring. Alright, so in summary, you guys all have the summary right here. Okay, so a transformation is just a function. Okay, you can say it by the function moving p, so function of p. Okay, it gives you some stuff, but remember we're just gonna use this p prime. Okay. We're going to be mostly interested in transformations that are given by rules. That is a step-by-step instruction that can be applied to any point P on the plane to get its image. If any 2 points P and Q, if given any 2 points, the distance between the images is the same distance between the original, and then the transformation F preserves distance or is distance preserving. It's just a rigid motion. Okay, so all we're doing is moving things in a rigid motion, making sure that we begin. Okay, we use this length and we just move it to see if it's the same length as this one. You can't see that. So we use this length and quote unquote move it to see if it's the same length as this one. So now I want you to work on this problem set. There's only 2 questions, and you have an exit ticket for this one that's in your module. You'll have to draw it on your own paper, take a picture, and put it in there in Canvas for me.